بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتناول درس جديد في مادة الهندسة الفراغية. مادة الهندسة الفراغية تابعة لمادة الجبر، وطبعا احنا عارفين ان الامتحان يعتبر جبر وهندسة فراغية في بوكلت واحد، وطبعا عليهم 30 درجة. درس بعنوان المتجهات في الفراغ. طبعا مهم جدا جدا ان احنا نعرف التطبيقات الحياتية او الرياضيات ازاي تطبقها في الحياة. المتجه هو عبارة عن كومبوننت او اكس اند واي. بنتكلم في 2 dimensions، لا اليوم هنتكلم على 3 dimensions اللي هو 3 ابعاد. مهم ندرس كل الحاجات الانشاءات الهندسية على 3 ابعاد، والعلم ده مهم جدا جدا في العلوم الهندسية. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in solid geometry. It's called vectors in space. My dear student, look at introduction about vectors in space. My dear student, solid geometry, vectors in space. Position vector in space of a point A has 3 components ax, ay, az with respect to the origin point 0, 0, 0 is defined as directed line segment whose starting point is O and end point is A, or a vector ax, ay, az, component of a vector ax, ay, az. Ax called component of A in direction x-axis. Ay is called component of A in direction y-axis. Also, AZ is called component of A in direction z-axis. Norm of a vector. What is the meaning of norm of vector? Length of the vector. If we have vector A, Ax, Ay, Az, then the norm A, its symbol, norm A vector equals square root Ax squared plus Ay squared plus Az squared. Is the length of directed line segment which represent the vector. What is the meaning of the norm? Vector length of the directed line segment which respect to the vector. Example. If we have vector A to negative 3, 1, vector B 0, 4, negative 3, then the component of vector A in direction x-axis, this number 1, the component of the vector B in direction z-axis is negative 3. Norm of vector A equals square root x squared plus y squared plus z squared. 2 squared plus 1 squared plus 3 squared equals square root 14. Norm B vector by the same method, square root 0 squared plus 4 squared plus negative 3 power 2 equals square root 5. The vector B lies in x, y, z plane. The component vector A vanishes equals 0 in direction of x-axis. Adding a vector in space. When we have two vectors in space as Ax, Ay, Az, component of vector A. Also other vector B, its component Bx, By, Bz. Then we deduce that C vector adding of two vectors, A vectors plus B vector. We have Ax plus Bx, By, Ay plus By, Az plus Bz, component of x plus component of x on the second vector as the same method component of y with component of y, component of z plus component of z equals Cx, Cy, Cz. This is the vector C. Example. My dear student, we have 3 dimensions x, y, z. Vector negative 2, 3, 1. How to determine negative 2, 3, 1? We can represent vector A by Determine negative 2 on x-axis and 3 on y-axis. Then we move 1 unit parallel to z-axis. Also, we have vector b 0, negative 2, 4. Then, when we add a vector plus b vector, we add component of x, component of y, component of z. Answer is negative 2, 3, 1 plus 0, negative 2, 4. Answer negative 2, 1, 5. We add each component of x, each component of y, each component of z. Now we are translate two properties of adding vector in space. Number 1, closure property. What do you mean closure property? If we have two vectors, a vector, b vector belongs to R3 or 3 dimensions, then a plus b vectors must be belongs to R3. And don't forget a and b belongs to R3. Commutative property. What is the meaning of commutative property? A plus b, b plus a. A plus b vector equal b plus a vector. Also associative property. If we have 3 vectors, a vector plus b vector inside bracket plus c vector equals a vector plus b vector plus c vector. If we add first plus second, then the result must be plus third equals. If we add second and third, then resulting with adding the first vector. 0 vector, identity element. Identity element 0 vector, 0x, 0y, 0z. A vector plus 0 equal 0 plus a vector equal a vector. When we add any vector with 0 vector equals same vector. Additive inverse. For every vector, a vector, ax, ay, az belongs to R3, there is additive inverse negative a vector, negative ax, negative ay, negative az. Belongs also R3. Don't forget, if we add a vector plus negative a vector equals 0 vector or identify, such that a vector plus negative a vector equal negative a vector plus a vector equals 0 vector. Multiplying vector by a scalar arced number. My dear student, look at example. If we have a vector ax, ay, az belongs to R3 and k belongs to R, then k a vector equals k multiply component of ax, ay, az. K ax, k ay, k az. Also must be belongs to R3. Look at, if we have 3 multiply 2, negative 1, 4, we distribute, multiply 3 times 2, 6, 3 times negative 1, negative 3, 3 times 4 equals 12. We distribute 3, multiply component of x, y, z. Also negative 2 multiply 1, negative 3, negative 4 equals negative 2, 6, 8. Properties of multiplying vector by real number. If we have 2 vectors, a vector, b vector belongs R3 and k and l belongs to R. R is real. Then distributive property. If we have k multiply bracket contains a vector plus b vector equal k vector plus kb vector. Also k plus l multiply a vector. What is the meaning of k plus l? K plus l belongs to real numbers. Multiply vector equals k a vector plus l a vector. We distribute k and l among a vector. Associative property. If we have k multiply l multiply a vector equal l multiply k a vector. equals KL multiply A vector. Now we are translate to example. My dear student, if we have vector A negative 1, 5, 2, B vector 4, negative 1, 3, find 2A vector minus 3B vector. It is easy. Also, my dear student, we put 2 multiply component of vector A minus 3 multiply component of vector B. By distribution, answer is negative 2, 10, 4, minus 12, minus 3, 9. Then negative 2, negative 12, negative 14, 13, negative 5. This is the final answer. Now we are translate to important example. Find the vector C vector where 2C vector equals 3A vector plus 2B vector. My dear student, in this case, look at the solution. C vector, 2C vector plus 3A vector equal TB vector. Then 2C vector equal what? X and student. 2B vector minus 3A vector. Divided, we can multiply 2B vector minus 3A vector at the first. After that, divided each component by 2 to calculate C vector. Answer is 8, negative 2, 6, plus 3, negative 5, negative 6. Then x plus x, y plus y, z plus z. Component of x, 8 plus 3, 11. Component of y, negative 17. Component of z, 0. Then multiply by 1 over 2 or divided by 2. Then C vector became half multiply the vector 11, negative 7, 0 equals 11 over 2, negative 17 over 2, 0 vector. This component of C vector. Equality of vectors in space. If we have two vectors, number 1, a vector, its component, ax, ay, az. Number 2, b vector, bx, by, bz. Then we deduce when vector A equal vector B if and only if ax equal bx, ay equal by, az equal bz. My dear student, look at important example. Find the value of L, M, N, which makes two vectors, a vector L minus 4, M square minus 3, 1, and B vector 5, 1, N square equal. We know that, my dear student, if we have two vectors are equals, then we deduce ax equal bx, ay equals by, az equal bz. Look at, my dear student, two vectors are equal, then we deduce ax equal bx. What is the component of ax? L minus 4, component bx 5, then L equals 9. Also, my dear student, ay equals by. Component of ay, m power 3 minus m power 2 minus 3. Component of by 1. Then we deduce m square equal 4. Then m equal positive or negative 2. Also, az, bz. By substitution about az equals n square, bz equals 1. What is the value of n? Excellent student. Positive or negative 1. This is the value of n. The unit vector, my dear student, what is the meaning of unit vector? Vector whose norm equals unit length as 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1. This unit vector finds the norm vector must be equal unit length. Example. If we have a vector negative 3 over 13, 4 over 13, 12 over 13 is unit length, because the norm A, when finds the norm A, square root negative 3 over 13 for all power 2 plus 4 over 13 for all power 2 plus 12 over 13 for 12 over 13 for all power 2 equals 1. Look at the norm A must be equals unit length. Fundamental unit vector. What is the meaning? IJK. We have I is called fundamental vector in x-axis 1 0 0. J fundamental vector in y-axis 0 1 0. But K fundamental vector in z-axis 0 0 1. IJK fundamental vector. I on x-axis, J in y-axis, unit vector in y-axis, unit vector in z-axis is called K vector. I 1 0 0, J 0 1 0, K 0 0 1. Fundamental vector, it is a directed segment whose starting point is origin and its norm is unit length. Example. If we have vector A 2i minus 3j plus k, also B vector negative I minus 2j, find number A 2a vector minus 3b vector, number B norm A plus B vector, and find norm A vector plus norm B vector, and we deduce that. Solution. 2a vector minus 3b vector. We multiply 2 by component of vector A, and 3 multiply component of B vector, then subtract. Answer is 4i minus 6j plus 2k plus 3i plus 6j. We have like terms, 4i plus 3i, 7i, 2k. A plus B vector, we find A plus B vector by 2i minus 3j plus k minus I minus 2j. Answer is I minus 5j plus k. Norm A plus B vector. What is the norm of A plus B? Length of A plus B vector. We find A plus B vector at the first. Find square root 1 square plus negative 5 square plus 1 square equals square root 27. This norm A plus B vector. But there is difference between norm A plus B and norm A plus norm B. Look at norm A, square root component of A power 2, components of A power 2, 2 power 2 plus negative 3 power 2 plus 1 power 2 plus norm B vector negative 1 square plus negative 2 square inside square root. Answer is square root 14 plus square root 5 not equals norm A plus B. You know that norm A plus B not equals norm A plus norm B. How to express directed line segment in space in terms of coordinates of each terminal? My dear student, look at OA vector plus AB vector. equals OB vector. AB vector equal OB vector minus OA vector. We know that, my dear student, from the vector in triangle OA plus AB equals OB vector. OA plus AB equals OB vector. In direction, look at in the opposite figure, OA plus AB equals OB. Also, if we subtract, OB minus OA equals AB vector. AB vector equal B vector minus A vector. Example. Look at, my dear student. If we have vector 8, negative 2, 3, 1, B vector 4, 0, 2, then, my dear student, AB vector, B vector minus A vector. We subtract component of X, component of Y, component of Z. 6, negative 3, 1, AB vector. But BA vector means A minus B vector. Negative 2, 3, 1 minus component of B, 4, 0, 2 equals negative 6, 3, negative 1. Then we deduce that AB vector not equals BA vector. But norm vector AB equal norm vector BA. Unit vector in direction of given vector. This is very important. If we have a vector equals AX, AY, AZ belongs to R3, the unit vector in direction of vector A is denoted by UA vector. Unit vector in direction A, it's denoted UA vector equals what? A vector over norm A vector. Example. If we have vector negative 2, 2, 1, the unit vector equal A vector over norm A. What is the unit vector? What is the vector A? Negative 2, 2, 1. What is the norm of A? Square root x and student negative 2 for all power 2 plus 2 power 2 plus 1 power 2 equals what? Negative 2 to 1 over 3. Then we can distribute each component x over 3, component y over 3, component z over 3. Then the unit vector became negative 2/3, 2/3, 1/3. The unit vector in direction A vector. My dear student, we know that equation of sphere x minus m for all power 2 plus x y minus l for all power 2 plus z minus n for all power 2 equals r power 2. What is the meaning of our radius? X minus L. What is the meaning of L, M, N is called center of sphere. We know that center of sphere negative half coefficient x, negative half coefficient y, also negative half coefficient z. Don't forget, my dear student, x square plus y square plus z square, its coefficient must be equals 1. Look at the example about equation of sphere. My dear student, determine the center and the length of the radius of sphere, which equation is x square plus y square plus z square plus 4x minus 2y minus 6z plus 11 equals 0. My dear student, remember, equation of a sphere must coefficient x square equals coefficient y square equal coefficient z square equals 1. The first, look at the coordinate of the center of a sphere. Its rule negative half coefficient x, negative half coefficient y, negative half coefficient z equals negative 2, 1, 3. My dear student, we know that the length of the radius of a sphere, its equation r equals square root L square plus K square plus N square minus D. What is the L? Negative half coefficient X. What is the K? Negative half coefficient Y. What is the N? Negative half coefficient Z. Then by substitution, R equals square root 4 plus 1 plus 9 negative 11 equal root 3 unit. My dear student, by the end of the lesson, we know that equation of sphere must be x square plus y square plus z square plus coefficient x, coefficient y, coefficient z plus constant equals 0. We know that x minus L for all power 2 plus y minus m for all power 2 plus z minus n for all power 2 equals r power 2 is called standard equation of sphere. And we know that general equation of sphere must be equal 0. If we have x squared plus y squared plus z squared plus 2x plus 4y plus 6z plus 7 equals 0, what is the center of a sphere? Center of a sphere, negative half coefficient x, half coefficient y, half coefficient z. And we know that, my dear student, when two spheres are tangent externally, if the length between two centers equals r1 plus r2, and when two spheres are disjoint, if we have the line between two centers more than r1 plus r2, when two spheres are tangent from internally, if mn or the center's line equals r1 minus r2. Also, if we have two spheres, one inside other, then the mn length equals smaller than r1 minus r2. This position of two spheres. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.